Okay, so there's part 2. Okay, so just now we use we represent our waves on the graphs. Okay, now we represent our waves on something called wavefronts. Okay, what is a wavefront? Okay, this definition, a wavefront is the imaginary line on a wave that joins all adjacent points in the same phase. What is this talking about? Sounds so confused, sounds terrible. Okay, and cannot be understood. Okay, so basically what it means is this. So I draw for you for example okay, so if I have waves like that. Okay, so imagine you are looking from the top. You are looking from the top view at various waves. Okay, and these are waves being sent out. And then I imagine a line, okay, it's an imaginary line, which I'm going to draw in red, that joins all the adjacent points that are in phase. So I draw a line connecting all the crests. I draw the line connecting all the crests. I draw a line connecting all the crests. So from the top view, I see 3 straight, parallel, equidistant lines. Like that. So when I draw like this, how many waves have I actually drawn? So if I draw like that, how many waves is this? 3? 1?
No. 2.5.
2? 2.5?
Isn't it 1?
Just no. Look at this. How many waves are this? 2. Why? Because here's a crest. Here's a crest. Crest to crest, 1. Crest to crest, 1. So altogether, 2. Okay, easy. You just remember, count the space, count the gap. So when the wave fronts are simply these lines, all these lines over here, you draw a line to connect all the crests, all the crests. Okay, this imaginary line. Imagine there are these imaginary lines, and then after that, you draw it out. Okay, you are looking from the top view like that. That means when you see the top view, you are seeing lines. So the space would tell you the number of waves you have. Okay, so that is wavefront. Easy to understand. The worst thing is the definition. Every school will ask you a definition, and a lot of people cannot remember because it's not an easy definition to remember.
Imaginary line.
Yeah, imaginary line. What are you talking about? Okay, which is connecting all the points which are in phase. Okay, so again, the calculation is not difficult. So what is the wavelength of this wave? 1.2. How you get 1.2?
6 divided by 5.
Yeah, 6 divided by 5. So you simply put there 6 cm. There's 5 waves, so this is 1.2 cm. Okay, so 6 waves. 6 cm rather, and then you count got 5 spaces, that means 5 waves, so 1.2 lah. Okay, then after that, you all do part B and part C. Okay, do part B and part C, should be able to do. Okay, the frequency 25 Hertz. Here I think quite straightforward. Then the period is 0.04.
But you were supposed to calculate 4. Left out.
Seconds, right?
Oh, sure. It's fine.
Is it too many zeros?
No.
Correct, Okay, then after that, to draw everything out, okay, what are you supposed to draw? Okay, displacement distance graph. Okay, so draw a displacement distance graph. Label axis displacement. Distance. Okay, when you do this, don't forget to label the axis units.
mm.
Over here is mm,
Down cm.
the one below is
cm.
Okay, alright, then after they ask you draw 2.5 wave, very easy. 1, 2, try to draw nicely. Okay, not so out of shape, mine a little bit out of shape.
Mine is way off.
Okay, so this is 2.5 wave, right? You want to, you can, of course, nothing to stop you from saying I want to start from the bottom. also can. Okay, you just make maybe a little bit more confusing for yourself lah. Okay, so once you have done that, I start from the bottom, you can start from the normal position, then you label. Okay, the amplitude is given as
3 millimeters.
3. So I write here 3, I write here minus 3. Okay, all these must label. So this is a very simple question, don't lose marks because you forgot to label. Okay, then 1. Okay, what am I going to label over here? This marking, what is this marking? What is this marking? Camus, what is this marking? How much is this? What value?
0.4.
Look, distance.
1.2.
Distance means wavelength, right? Okay, so be careful. So you might make a mistake. 0.04 is not because it's a distance graph. So here is 1.2. Then over here would be 2.4. Okay, so you just label like that, and with the axis labeled correctly, draw correctly, very, very easy. Okay, so a wave front is like looking from the top view. Okay, but you can't tell the amplitude, but you can tell the wavelength, right? Okay, so to demonstrate wave front, they have this thing called what they call a ripple tank. Okay, so a ripple tank looks like this. Okay, our school has a ripple tank, very old ripple tank. Okay, it is I don't know whether it can still work. Okay, then last time, many years ago, in the syllabus, they used to ask a student, draw the ripple tank, describe how it works. The student is complaining, how are you supposed to draw a ripple tank? The ripple tank, you cannot draw, then you draw side view. So I gave them a side view drawing. So this is one of my students' notes. He drew this. It's a ripple tank, side view. I teach them how to draw side view because you can't draw 3D, right? Okay, draw side view. Okay? So this guy who did this is 35 years old.
Oh, sure.
Now he's 35 years old. Okay? Just had one baby daughter.
19 years ago.
Yeah.
Because it's like that screen recorder. It's still going up, no one's there.
Okay, so to create plane waves, Matthew, all we need to say is vibrate a horizontal bar at the surface of the water. Then you will see this kind of what you call straight line waves. Okay? There was once last time I asked a student draw a plane waves, right? And you know what he drew? He drew this.
Oh my.
I asked them to draw 3 plane waves, and he drew for me 3 waves. He drew for me 3 aeroplanes.
I mean, plane waves.
Yeah, he wasn't listening in class. Okay, so obviously you measure here for the wavelength, right? The gaps will give you the wavelength. Okay, and there is your plane waves. Okay, then if you want circular waves, vibrate a spherical. Okay, actually you can say pencil, or these, a lot of things can work. A spherical dipper at the surface of the water. Okay, it's at the surface not of water, not inside the water. It has to be on the surface of water. Okay, then when you draw this one, use a compass and pencil to draw. So you draw like that, circles. And draw like that. You freehand, you're going to lose your marks.
Huh.
So obviously, if you want to find the wavelength, measure from where to where?
The radius.
The radius?
No.
Where do you think? Use common sense. For
The
the plane
gap,
waves,
gap,
the
gap,
gaps.
gap.
So the wavelength will be here to here. Correct. Okay.
Yeah.
So very simple. So just know how to create these plane waves, how to create these spherical waves, how to draw, which is very easy, and how do you get the wavelength, okay, which is also very easy lah. Just basically count the gaps. Okay, so that's not very difficult. Okay, you don't need to know how to draw a ripple tank, don't need to describe how it works and so on.